In this picture, what you see here is something that has a lot of meaning to me. This is the building I lived in when I went to college. It's a kind of a special place. But really the only reason I even bring it up is I needed a street that we could look at, that we could walk down, and you know what you know. So this seemed like a fun place to look at. So let's look at an overhead satellite view of this. And you can see this building right here is the building that we were talking about. And so what we're going to do is we're going to start right here. And my question is going to be, who walked farther? So let's look at first person. Let's say this is me. And I walk 275 feet in that direction, the rest of the block basically. And let's say there's you, and you walk 275 feet that way. Now, don't think too hard about this. Not a trick question, not anything else going on here. Who walked farther? Now that you've answered that, let's look at this and see if it changes your mind. Now all I've done is put a number line. And so what we can see is that I end up way down here at negative 275. You end up way over here at positive 275. But the question remains, who walked farther? I hope that you see that we still both walked the same distance, even though these numbers now seem different. If we were to ask about my position, I'm at negative 275, you were at positive 275, but that doesn't mean that I walked the negative distance. My legs are still tired, like I walked 275 feet, as if your legs get tired walking 300 feet. But anyway, all this means, if we look at this in terms of the number line, it doesn't change anything other than now we think of this direction as being negative and this direction as being positive. And that is in fact exactly what I want you to see from this, is that negative signs just give directions. So the distance doesn't actually change. It's just the direction that changes with this sign. And here's where we're going with this, because I can hear you being confused in your mind. We're looking at something called the absolute value function. And the absolute value function is a new operator. And when I say operator, I mean just like multiplication, division, subtraction, addition. This is just a new one of those. And so we're going to look at what that means, how to simplify that in an expression. And most importantly, we're going to look at the function graph of y equals the absolute value of x. So by the time you're done with this, you should know what absolute value is. You should be able to simplify absolute value expressions, and you should be able to graph the function y equals the absolute value of x. So think back to what we talked about. We had the distance, where whether it's positive or negative didn't matter. It was just how far from that starting point we walked, and it turns out that that's exactly what we're looking at with absolute value. Absolute value is just the distance between whatever number we're taking the absolute value of and 0. That's it. And if we write the absolute value function the way we write it is as two vertical, that means straight up and down lines, and it's acting on whatever's in between them. So let's take a look at these 2 points. We've got point A, which is at the location 2. So if we were to take the absolute value of A, that is the distance between A and 0. So when you look at this thing, you would read this as the absolute value of A, but all it's really saying is how far is A from 0. And so we know A is 2 away from 0. So notice that the absolute value function didn't actually change anything right there, other than in our minds, what are we looking at? So now let's look at B, because something will change here. B is at negative 4. That means we, starting from 0, walked 4 in this opposite direction from where A was. So now if I want the absolute value of B, that means the distance between B and 0, and that distance is 4. So notice that's very different from negative 4. We don't need that negative sign anymore. We just say that the absolute value of B, the distance between B and 0, is 4. And that's all the absolute value function means. Now here's the shortcut. And I do want to stress that this is a shortcut. This is not the actual meaning of the absolute value operator. This is not what it is. This is what it does. And those are two very distinct things. Is that if you want the shortcut for numbers, the absolute value function always makes the number positive. So here, if I take the absolute value of -4, it just makes it positive 4. If I take the absolute value of 2, it makes it positive, which it already was, and it's still 2. So having that definition and that shortcut in mind, let's look at some examples. So first of all, I want to simplify the absolute value of 6 plus the absolute value of -4. So I'm going to start by just rewriting the function, or the functions, as they were. And now I'm going to simplify. And when you're simplifying this, we have to follow the order of operations. So parentheses, exponents, multiplication, division, addition, subtraction. And the absolute value function, the absolute value operator, is considered a grouping function. So it is going to happen in those first steps, almost as if this were a set of parentheses. So I take the absolute value of 6, the distance between 6 and 0, and that's 6. And then I can take the absolute value of -4, that is the distance between -4 and 0 is 4. And so this whole thing simplifies to 10. And that's it. That's all that's going on there. It's nothing more than that. Let's take a look at some more examples. Simplify the expression when f is equal to -2, and then I've got the absolute value of 3 plus f. So what I'm going to do first is I'm going to make my substitution. Take f and replace it with what f is equal to. Now remember, I deal with this absolute value operator as almost as if it were parentheses. So it's the first thing I'm going to evaluate. So I want to do everything inside first. 3 plus -2 is 1. So I have the absolute value of 1, and the distance between 1 and 0 is, of course, just 1. And so that's my answer. That's all that's going on here. For number 3, simplify the expression when g equals 4, and now I've got a lot going on in this guy, so let's break this down. We're going to write it just as it was, with the exception that I'm substituting in my value for g. Notice that I did that inside parentheses, so take the g, replace it with parentheses, and then put the number that g is equal to in there. Now, because this acts as if it were parentheses, I have to evaluate what's inside of it. -4, and then I'm going to take the absolute value of -4, and the absolute value of -4 is +4. Now note what's going on here with this 3 and the absolute value of -4. Because they're written right next to each other, just like with parentheses, this means we're multiplying. So I need to indicate that we're multiplying 3 times 4, which is, of course, 12. And 10 minus 12 is -2. So notice that just because there's an absolute value operator in there doesn't mean the final answer has to be positive. It just means you take whatever is inside that, and it's going to end up being positive because it's the distance between that number and 0. Now, for what we really came for here, hopefully you understand what the absolute value operator does. But really what I wanted to show you is what the graph of the absolute value function looks like. That is, if I take the equation y equals the absolute value of x and I graph this, what does it look like? And it turns out the shape is maybe more interesting than you thought. So let's take a look at it and let's just plug in some points. Let's see what happens. Let's start with x being 0. Because that's nice and simple. So to find the y value when x equals 0, all I have to do is replace my x with 0, and the absolute value of 0 is 0. How far is 0 from itself? It's not. It's there. So I have the point 0, 0, and can now graph that. So let's try 1. So if I replace x with 1, I get the absolute value of 1, which is 1. So I would graph the point 1, 1. And I can do the same thing for 2. And I take the absolute value of 2, and it is 2. And so this will just continue on and on if I keep going with bigger and bigger numbers. And it just ends up being a straight line. And so that's nothing really fancy or exciting or anything. But watch what happens when I start using negative x values. If I let x be negative 1, then y is the absolute value of negative 1, which is positive 1. The distance between negative 1 and 0 is 1. So at negative 1, I get 1. And at negative 2, well, now I'm taking the absolute value of negative 2, which is positive 2. And this will continue forever. And so what happens is that as I continue plotting these points, I end up with this function that's shaped like a V. And this is what happens when I graph the absolute value function. And this is very intimately related to the definition of the absolute value operator, because check out what's going on here. The y value is simply a measure of how far the x value is from 0. So when I go to positive 1, that is 1 away from 0. When I go to negative 1, that's also 1 away from 0. At 2, my y value is 2 because I'm now 2 spaces from 0. And negative 2, my y value is positive 2 because I'm still just 2 spaces away from 0. So the fact that this is a V shape is a direct reflection of the fact that the absolute value operator just gives us our distance between whatever we're operating on and 0. So let's take a look at some of the features of this graph, because I do want you to have these memorized. So the first thing that I need you to know about is this point right here. We said the absolute value function is V-shaped. And it does come to a point, not a rounded point, a sharp elbow like a V. And that point has a name. We call it the vertex. And for y equals the absolute value of x, that vertex is always at 0, 0. We will look at other variations on this function where the vertex is something else. But if our equation is just y equals the absolute value of x, the vertex is going to be at 0, 0. And the v is constructed of two arms that come out from the vertex from 0, 0. They go on forever in both directions. And the slope of the right arm is going to be positive 1. If I measure the slope of this, I'm going up 1 over 1, up 1 over 1, up 1 over 1 forever. So this side has a slope of 1. Over here, I'm going down 1 and over 1. So the left-hand side has a slope of negative 1. And something you'll notice about these absolute value functions is that the slope, the number of the slope rather, will be the same on either side. It's just one will be positive and one will be negative. So we have the vertex, and we have these two arms coming out at a V. They do meet at a point. The right side has a slope of 1, and the left side has a slope of negative 1. So, to cap it all off, again, this is the list of stuff that I want you to remember about the graph of the absolute value function, and you do absolutely have to have this committed to memory. The graph is shaped like a V. That point of the V is called the vertex, and it is a point. It's not rounded. It is a poke you in the eye kind of point. And the line to the right of the vertex has a slope of 1. Line to the left of the vertex has a slope of negative 1. And we will be drawing these and looking at the equations for them over the next several days. So hopefully you will get very, very familiar with them.